right, hey there. Coming to you live from the lab room here today, doing a quick lab on percent composition. So I got all my tools laid out here, all the devices I'll need. Here is the lab. Hopefully you've been able to print it yourself or got a copy from me. And the first thing we have to do, balance. First thing we need to do is find the mass of our empty dry crucible. So this is a crucible, just a little cup we use, ceramic cup that we use to heat things usually. All right, so there we go. 10.40 grams. Now next up, I'm going to put a little bit of salt into the crucible. Now, here's the interesting thing about the salt we're using today. It is iron sulfate heptahydrate. So normally we think of water as dissolving salt. Well, interesting thing about this salt is that this is salt with water dissolved in it. So you can't tell when you're looking at it, but in this salt here, there is water kind of trapped inside the crystal structure. So that's what a heptahydrate is. So throw that back on the scale, see what we get. 10.63. All right, so the next step then is what we're going to do is we're going to figure out the percent of water that is trapped in there. How are we going to do that? Well, we're going to set our crucible with salt in it onto a hot plate. Already got going, so it already shouldn't take too long. All right, so it's getting warmed up on the hot plate there. I'm going to go ahead and press pause in the video because it takes about 10 minutes or so for it to heat, and we're going to evaporate out the water. While I do that, though, you can work on this part here. So finding the theoretical percentage of water in the sample. You'll need to use your periodic table and add up the masses of your iron, your sulfur, 4 oxygens, 14 hydrogens, and 7 oxygens. So add all that up. Kind of a special note, a lot of people in class that looks like a multiplication symbol. It does, I know. It's just how they write heptahydrate. That's how they write all of our hydrates. So you can see it on the bottle there. There's that little dot. So it's just the way that they write it. It's not a multiplication symbol. Do not multiply by 7 H2Os. So it's kind of a mistake a few people made in class. So watch out for that. So that'll be the total mass on the bottom. And on the top part, you want to add up your 7 waters. So 14 H's and 7 oxygens on top. And then you can do that number will be your theoretical mass. And we'll see in a little bit here if how close our theoretical mass is to the actual mass. But again, I'm gonna leave you here for a few minutes. I'm gonna let this do its thing with that water. Back now, you can already see it's kind of starting to change colors just a little bit. So we'll come back. Hopefully, we have a really dark brown color to it. You can see it happening again on the outside left edge. But we'll see in just a minute. When we come back. All right, back again. Probably didn't feel like 10 minutes to you guys. Probably feels like I just went off the air, but through the magic of television, we just waited about 10 minutes. So let's take a look at what's doing. And you can see it started off with kind of that whitish color. Now it's a very dark brown color. Good indication that we have evaporated all the water off. We call it driven all the water off. And so now, carefully using hot hands, I'm going to remove it. I'm just going to set it down on the black tabletop here to cool for a few minutes. Cooling. These tabletops are black tabletops are like impervious to heat, so very safe place for it to be is just there on the countertop. And again, I'm gonna wait about 2 or 3 minutes, let it cool off before we find the mass of it again. So I'm gonna put you guys back on pause. I think that seemed to work pretty well last time. I'll see you guys in about 2 or 3 minutes. All right, welcome back. Again, doesn't feel like more than a few minutes, a few seconds probably for you, but it's been a few minutes now. And our sample has successfully dried. Cooled. Hopefully dried as well, because that's what we're trying to do, is find the how much water has been driven off. So got my dry sample. And we'll put it on the balance there, and that is the massive crucible. It's the third data point here, your massive crucible and anhydrous sample. So anhydrous means dried sample. All right, so there we go. You have all the data you need now to figure out this lab. Again, you probably had time to, well, I've had more time to work, but to figure out the theoretical percentage of water. A couple of calculation steps, subtraction to figure out how much water was driven off and how much hydrate you started with. Make sure you guys are showing your work for these steps. That's what I'll be looking for, is, are you showing your work? And then finally, your experimental percentage of water and a percent error. You're going to be comparing the experimental percentage of water with your theoretical percentage of water. See how close to the actual value you got. All right, well, good luck. Hopefully this helped, and we'll see you next time.